solving polynomial equations. Doesn't that solve these? Even that one's a little tricky. This one, we'd add 27. So it equals 0. Factor it to find the values of x that make it equal 0. Nine and 3. Multiply the 27 and the 12. So the values of x that make it equal 0 are negative 9 and negative 3. You put those numbers in the number line. Because the solution to this inequality, the numbers that are less than 0, are numbers that make it negative. So if you plug in a number like to the left of negative 9, negative 20, you get a negative times a negative, which is positive. That's not bad. So those numbers are not solutions. You choose a number between negative 9 and negative 3, like negative 5. Make this positive, that negative. Positive times a negative is a negative. And negative numbers are solutions to this. You choose a number bigger than negative 3, like 0. The positive times a positive, which is positive. Positive numbers are not solutions. So the answer, the solution to this equation, are all numbers between negative 9 and negative 3, and including negative 9 and negative 3. Those are the solutions. Inequalities, especially quadratic inequalities, are a little bit tricky to solve. Find solutions of a polygon, polynomial equations, and zeros of polynomial functions. Use rational root theorem, and use the irrational conjugates theorem. These are all cues. How would you notch these up? Well, this one, we factor into the zeros are 0, positive 2, and positive 1. Negative 2 and positive 1. 0, negative 2, positive 1. So that's an opposite. You notice these coefficients 1, 3, 3, 1. What does that remind you of? 1, 3, 3, 1. Yeah? Yeah, pastel stripe. This one actually is x plus 1 to the third power. That means negative 1 is the 0. And it also means it's a repeated solution. So it goes through, or Well, since it's an odd power, it goes through the x-axis kind of in a third degree kind of a way. You know, when you graph y equals x to the third power, it looks just like this, except it goes through 0, 0. X to the third power. Now, if we wanted to shift this one to the left 1, you'd add 1 to the x, and that would move it to the left 1. But this is what a polynomial looks like when it goes through the x-axis, when the multiplicity of that solution is 3. This is what it looks like when the multiplicity of a solution is 2. So this one, if I were to write out the factors, it would be x plus 2 and x minus 1 to the second power. This one is x plus 1 to the second power times x minus 2. This one is x minus 2 to the third power. It's probably this one. Because it's a third power, so the coefficients would be 1, 3, 3, 1. But the powers on the second parenthesis would be to the fourth power. It wouldn't be negative. Goes up. It would be in the third power. Negative 2 to the third power, which would be negative 8. I think that's correct. Anyway, this one, since it goes through at negative 2, the factor is x plus 2. This one goes through positive 1, so the factor is x minus 1. Goes through 0, so that just adds another x. That's this one factor. Anyway, just stuff that will be helpful for you to know when you do these problems. Okay, so let's do it. This one you'll definitely see. How do you solve that? I think you can do it right now. You want to answer it or give me a number? I know what you want to do. You want to answer. How do I do this one? Just solve this equation. Factor what out of it? 2x comes out. With x squared minus 6x plus 3 plus 9. Is this factor?
Yeah. X minus 3, x plus 3. Wait, minus, my bad.
So 2x times x minus 3 squared. Okay? The multiplicity of this solution is 2. Since the degree of the polynomial is 3, there will be 3 solutions. One of the solutions, x equals 0, and the other 2 solutions, x equals positive 3. If we were to graph this, something you need to know, it would go through the x-axis at 0 and go touch the x-axis at positive 3. But it won't go through it, it'll just touch the x-axis and bounce back up. If I were graphing this, I know since the leading coefficient is positive, the right side goes up. And it's odd, so the left side goes down. So if I were to graph this, I'll go something like that. Maybe a little curvier here. I could do that. Information you do need to know. Find the zeros, then sketch the graph. Find the zeros, then sketch the graph. Alfonso. So let's do the same thing.
You can
If there's something to factor out, we take it out. What can I take out? Good. I'm going to take out a -2 so that leading coefficient is positive. Okay? This is
x2, x2. Four, four.
Thanks.
Uh, 4x.
Okay. X and 2. X and 2.
Yeah, x2, x2.
What are the signs here if I'm factoring x squared?
One- one negative and one positive.
Right. And then these two?
The same.
So we can rewrite this -2 x minus 2 squared x plus 2 squared. Okay. So where does this the zeros are x equals 2, x equals -2. That just means the zeros means where does it cross the x-axis? Or where does it touch the x-axis? Touches at -2 and +2. Okay. Now, let's sketch the graph. What is important is that you know where the zeros are and you put those down. It's also important that you know how it's going to go through or not through the x-axis. Since the multiplicities of these zeros are 2, an even number, does the curve go through the x-axis or not through the x-axis? I can give you some famous multiplicities. Like if we graph y equals x squared, that's famous. When it touches the x-axis, when you graph it, it just touches in one spot. If you have an even multiplicity, it does not go through the x-axis. It touches in one spot and goes back up. Or if it touches in one spot and goes back down. It does not cross the x-axis. Y equals x is a famous multiplicity when the multiplicity is 1. And that does cross the x-axis. Just goes through it normally. Y equals x to the third. It's odd. It will cross the x-axis, but it does it in a kind of funky way. It crosses the x-axis, but it doesn't keep the same concavity. It switches concavities on the way through. It's an advanced thought. But if that makes sense to you, that's very good. So, at +2, does it go through the x-axis? Anybody can answer. No, it does not. Even multiplicity means it does not go through the x-axis. At x equals -1, does it go through the x-axis? No, it does not. So how are we going to graph this? Leading coefficient's negative, what's the right side do? Goes down. I can draw that in right now. Leading terms of the power is 4. What's the left side do? Goes down as well. So somehow I have to graph this. I have to touch the x-axis, not go through in those 2 spots. I do know that if I plug in 0, I get negative 32. Now, obviously, negative 32 isn't going to fit on this. But the curve goes down, and then at negative 32, it connects. And you can, if you're sketching it on the test, you can, it's okay that it doesn't cross the x-axis in the right spot. What's important is you know how it touches the x-axis, and you know what the right side does, and you know what the left side does. As long as you get those 4 things in this case, the 2 zeros, the left side and the right side, all correct, you'll get full credit for this on the test. Does that make sense? Solve the equation. This is really enormous. Are you guys solving these right now? I'm giving you some time. Solve the equations. Brett, you're first.
Take 4 out.
Fine.
X squared.
Do you know what the signs are?
Negative.
Good job. So what are 2 numbers that multiply to 9, but add to 10? You multiply to 9, they add to 10. Right? 3 and 3 you don't multiply. I mean, you multiply to 9, but they don't add to 10. 9 and 1. So does this factor and this factor. multiply to 9, but they subtract to 0. Because there's no middle term. 3 and 3. 1 plus 1. How about these? So if this said y equals or f of x equals, we could graph this as well. Oh, let's finish solving it. Solving the equations, could you tell me what the values of x are? Right. -3, 3, positive 1, negative 1. Right? So if we could graph this. And we're to graph this. Those would be the zeros. 1, negative 1, 3, negative 3. Since the leading coefficient is positive, the right side goes up. And it's even, so the left side goes up. Right? And all the multiplicities on these factors is 1, so it goes through, goes through, goes through, goes through. Right? Goes through, goes through, goes through, goes through. And that's it. See how if you plug 0 in, you get 36. That means the y-intercept is 36. Well, of course, we can't graph that exact point, so we'll just leave it just like this. As long as the right side and the left side are correct and it goes through the x-axis or touches the right way, give full credit. Okay, Maddie? How about that one? This, like in some pretty advanced math, it does factor. What's the same number times the same number that equals 3? Kind of like, yeah. Oh, you're kind of right. Kind of right. What is it? Yeah? Kind of. Same number times the same number equals 3. Come on, each right. What is it? Square root of 3. So it does factors in x minus the square root of 3, x plus the square. Now if you can't factor it, not a big deal. You can take this factor, because we're looking for the value of x that makes it 0. And solve that equation. Right? Add 3, x squared equals 3. Square root both sides, plus or minus, x is plus or minus the square root of 3. We can still get the same zeros out of it. Right? However, what are we looking for? Are we solving this equation? Yeah. So we're solving it. These are the solutions. X equals 0, x equals 2, x equals -2, x equals square root of 3, x equals negative square root of 3. And we should have five solutions. The multiplicities on each solution is 1, so there's 5 different answers. Any questions about that? Does it look too difficult? We could even graph this if we needed to, right? I'll do it in blue on the center graph. Okay? So it goes through at 0, goes through at 2 and -2. And the square root of 3 is like, what'd you say, 1.5? It's probably closer to 1.7. Or 1.7. So we know the right side is odd. I'm sorry, positive, so it goes up. All the multiplicities of 0. Oops. Too crazy. So it just goes through the x-axis once. So it goes through, down. And that's what it looks like. All the zeros in, through, down. Okay, any questions? Okay, so these are the ones where we're supposed to graph. Hopefully you know enough that graphing these isn't so bad. No. Where are we going to graph this? Yeah, for sure. Factor 3 out. What's left? Okay, is that factor?
It's x squared. -1
Is it still factor?
yes. X minus 1, x plus 1. X minus 1,
So factors into 3, x minus 1 squared, x plus 1 squared. Now let's graph it.
the dot on 1, 0. -1, 0.
Does it go through at those points? Multiplicity of those is 2.
So, no.
Just like all the other famous even powered functions. It doesn't go through the x-axis. Good. No. Okay. What's it do on the right side
Go up,
and the left side?
also up.
Good. When x is 0, what's y?
3.
3. We can plot that point. X is 0, y is 3. You said the left side goes up, right side goes up. Does it go through? Stays up, so it goes. Okay, and that's it. Any questions? Nora, you ready? What factors out?
X.
X factors out. What's left in there?
X squared plus x minus 6.
Is that factor? Negative 2 plus 3. Good. Inside's -2, outside's +3, goes into +1. This is correct. What are the zeros?
X equals 2, X equals 3.
+2, 0, and -3. Okay? What's the right side do? Good. What's the left side do? Look at the power now. It's odd. So it's opposite. Right? Odd, opposite. The right side's up, opposite of up is down. Left side is down. Now when I graph these, should I go through? Or bounce off? Okay, I had 2 on these. Look at the power on that factor. If the power is 2, it does not go through the x-axis. If the power is 1, 1, 1, it does go through. So it goes through, goes through, goes through. Goes through, goes through, goes through. And that's what it looks like when you graph it. Any questions? Okay. The rational root theorem is a way to figure out all the rational roots just based on the ending number in the polynomial and the leading coefficient. Let me give you an example. Y equals x squared plus 0x minus 9 minus 4. Okay? If you look at the last number, 4, find all the factors of 4. You look at the first coefficient, 1, and find all the factors of 1. All the possible roots, all the possible zeros, all the possible numbers that make the value of this 0, you can make as fractions with these factors of 4 on the top and this factor of 1 on the bottom. Like this, 1 over 1. That's possible. 2 over 1. Those are possible. 4 over 1. Those are possible. Of course, the zeros are positive and negative 2. But all the possible ones are the factors of the last number, factors of the first number, all the fractions you can make out of those numbers. Okay? Anyway, let's try it out. Find all real solutions. Now, the question is not find all possible real zeros. That's what you use the rational root theorem for. So let's do this one, all possible real zeros. You take this number 12, find all the factors of 12. And we take this number 10, find all the factors of 10. And we'll make all the fractions, positive and negative fractions that you can make with the factors of 12 on the top of the fraction and the factors of 10 on the bottom of the fraction. It's going to be a lot of numbers. But the factors of 12 are 1 and 12, because 1 times 12 is 12. 2 and 6, because 2 times 6 is 12. 3 and 4, because 3 times 4 is 12. Those are all the factors of 12. And all the factors of 10. 1 and 10, because 1 times 10 is 10. 2 times 5 is 10. And those are all the factors of 10. Now, what you do is you make all the fractions you can make with these numbers on the top and those numbers on the bottom, like 1 over 1, and 1 over 2, 1 over 5, 1 over 10. Okay? Those are all the fractions I can make with 1 on the top. Let's do all the fractions you can make with 2 on the top. 2 over 1. 2 over 2 is 1, I already have it, so I'm not gonna put it down. 2 over 5. 2 over 10 is 1/5, I already have it, so I'm not gonna put it down. Make all the fractions you can make with 3 on the top. 3 over 1. 3 over 2. 3 over 3 is 1. Oops, I don't have 3 over 3. 3 over 5. 3 over 10. Okay? Now all the fractions I can make with 4 on the top. 4 over 1. 4 over 2 is 2. I already have it. 4 over 5. 4 over 10 is 2/5. I already have it. Now let's make all the fractions I can with 6 on the top. 6 over 1. 6 over 2 is 1/3. I already have it. 6 over 5. 6 over 10 is 3/5. I already have it. Now all the fractions I can make with 12 on the top. 12 over 1. That's probably the only one I can do. 12 over 2 is 6. I already have it. 12 over 5. Oh, I don't think I have it. 12 over 10 is 6/5. Already have it. That is finding the possible real zeros. You look at the coefficient, you look at the number, the last number in the polynomial, put that on the top. And the first number in the polynomial, put that on the bottom. Find all the factors of each of those, and then make all the fractions you can make with these numbers on the top only, and these numbers on the bottom. Okay? Now, this one, find the solutions. Like, how are you going to do that? You can factor by grouping, that's not going to work. It's 4 terms. Now this is what, this is what you need to do. You need to graph it on your calculator and see where it crosses the x-axis. And then act like you didn't do that. When I was in school, we didn't have calculators like graphic DVD. We really had to use the P over Q and then try numbers out until you found one. You can do what?
We can do grouping with this.
I'm not sure what grouping is.
¿Tú cómo se dice grouping en inglés? ¿Cómo se dice grouping en inglés? ¿Qué sí con esto? Alfonso is asking if that equation we can do like in the last test with this.
Synthetic division?
Yeah. Con esto estoy full.
Is that it? So the answers of this will be -1, 4, and 5. See it? I'm looking at it. -1, 4, 5. I can make sure those are the answers. I can put -1 in, do I get 0? Yes. 4 in, do I get 0? Yes. 5 in, do I get 0? Yes. So -1, 4, and 5 are the solutions.
How do you get that?
I just looked to see, I graphed it and just looked to see where it crossed the x-axis. Crosses the x-axis at -1, 4, and 5.
I just got one line, and it shows at -2.
It's -8x squared.
Why is this thing so greasy?
minus 8x squared, just get the right numbers in, good. Okay, negative 1, 4, and 5, here's the answer. X is negative 1, x is 4, x is 5. But that, the work is what I'm interested in. I'm interested in you using synthetic division with one of these numbers. Okay. It's 19. Still not gonna, oh no, it's 20. Oh. 20 times negative 1 is negative 20. So see, I've got this left. This is what you can do. You can apply x's, factor it, and then get full credit. You have to find these, use synthetic division to get rid of one of the degrees. Now it's a quadratic, and you can factor it.
Wait, what?
All right, good luck.